Okay, so we are going to talk about perpendiculars and distance. So when we are looking at distance, we're looking at lines that are perpendicular. So the distance from something has to be the straight 90-degree line from whatever the point is that I'm going to whatever I want to. That's your ultimate distance, how far apart they are, more than just like, I think sometimes we think of distance as just like the length between one point to another. But when we're looking here, what really represents distance is like something that is like exactly perpendicular from wherever I'm at to wherever I'm going. So it can almost be in line with it. So we'll kind of look at that. We're going to construct it, and then we're going to find the distance between a point and a line, and then the distance between two lines, two parallel lines. So equidistance means that we have kind of this word equal and then distance. So it's saying that everything on that is the same distance away. So when I look at a perpendicular line to another line, then each of the points on there is the same distance across from it, like on both sides. So it's all the same distance. So the distance between a line and a point not on the line is the length of the segment perpendicular to the line. So it has to be exactly perpendicular to it in order for it to be the distance. So the only line that represents distance is this one that's perpendicular. And this length then would be the actual distance to this line. Remember that lines go on and on forever. So even if I'm looking at this line and the line is only represented by like a small part, I can always extend my line out so then I can draw the straight distance to it. So the first part is going to be constructing. So if this is the perpendicular postulate that talks about that if I given a line and a point not on a line, there's always a perpendicular line from that point to the line. But first we're going to look at constructing a perpendicular line. So a certain roof truss is designed so that the center post extends from the peak of the roof, point A here, to the main beam. Construct and name the segment whose length represents the shortest length of wood that will be needed to connect the peak here to this beam. So what you would do, and it's going to be kind of hard on the video to show, but what you're going to do is you're going to set your compass so that it's further than the actual distance. So you're going to kind of eyeball that. You want it to be further than the distance. And then you're going to put the pointy part of the compass on this point that I'm drawing the line from, and you're going to make an arc that crosses. So you can see here's this arc. That arc crosses the line twice, and then not moving the length apart that your compass is, you're going to put your pointy part on each of the points that it this arc intersected, and draw another arc down below from each point. So I'm going to put my pointy part on S, swing an arc there, put my point part on, that's probably not real technical, on R, and swing an arc here. And that should make this X. And if I connect from A through those X, that will help me draw my distance. So again, that's kind of hard to do without you being able to see the compass. And then I could measure this is the true distance from A to this B. So let's look at one that's it's actually on your homework. We want to draw the line that represents the distance from G to EF. And so remember again, like say I wanted to go from F to GD, the straight distance would be straight down. So I could always extend this line out. So remember that when I'm looking at the distance between a point and a line, if I can't like connect it straight on, I can always extend out my line. So what I would do is take and set my protractor not protractor, my compass, so that it's longer than what I see as the distance. So I might be like about this far apart from here to here, setting that protractor apart. And I'm going to swing an arc below this so that it crosses my line twice. And then I'm going to put my point of my compass on each of these points and not setting the distance apart, and I'm going to swing an arc here and swing an arc here. So I have this X, and I'll connect the X to my G, and I'm kind of just eyeballing this. Actually should be about here. So that I then can draw my straight distance that connects between these arcs that I have. Again, hard to see on there, so if you need, you can come in and we can go through that one-on-one. But this line then from here to this point represents the distance. So when you see that representing the distance, that's what we want to draw. So easy to do if I have a compass, just need a compass and a ruler. I can do that. Let's look at it on a coordinate plane. So I'm going to show you two different ways to do this. One, I'm going to show you just total algebraically, and then I'm also going to show you on the coordinate plane, because again, we want to always show both because we've got visual learners and some not. So we have this line S that contains these points, and we just got through a unit that talked about how we can write, or just got through a lesson that talks about how we write the equation of a line given 2 points. So remember, we found the slope first, so we're going to do that. We're going to write an equation of line S. So we're going to find our slope first. So I'm going to subtract my y's, 5 minus 0, and subtract my x's, negative 5 and 0. And I get 5 over negative 5, which equals negative 1. So that's the slope of my line. And then I'm going to pick a point. Let's pick 0, 0, because that's going to be really easy. And I'm going to write my equation. So y minus the y of my point, 0, equals my slope, negative 1, x minus the x of my point, in this case is 0. So when I simplify this out, I get y equals negative 1x. So that is line S. Again, I'm showing you first how algebraically how to do that. And so we are going to make a line that goes through this point and is perpendicular to this, because perpendicular is the true distance. So now we have to figure out what's the slope of my line that goes to this point that is perpendicular to it. So my perpendicular slope is, remember, we flip it and change the sign. So it'd be 1 over 1 positive, or just 1. And it's going through the point 1, 5. So I am going to write that equation, y minus 5 equals x minus 1. Distribute your 1. Y minus 5 equals 1x minus 1, and add 5. Y equals 1x plus 4. So I have these two lines, and I need to find the distance. So distance between 2 points. I know this line goes through this point, and to know where these connect, where this line here connects with line S, I'm going to put them equal to each other, because that's where they cross, would be where they're equal. So I'm going to put this negative 1x equal to 1x plus 4. So when the y's are equal, the x's are going to equal. And I'm going to subtract the 1x over. I'm going to solve for x. So negative 2x equals 4. Divide by negative 2. X equals a negative 2. And so where they cross is at negative 2 and I'm going to plug -2 into one of these equations and find y. So let's plug it into here. Y equals -1 times -2, which is 2. So they cross at -2, 2. So it goes from this point, 1, 5, and -2, 2. And we can find that distance. Remember, distance is change in x's. So 1 minus a -2 squared plus 5 minus 2 squared, which equals 3 squared plus 3 squared, which equals the square root of 9 plus 9, or 18. And then you could plug that in and find the decimal of square root of 18. So that's one way that I can find that distance. Or the other way, which if you're more visual, is going to be, let's draw S. So 0, 0, and -5, 5. So I have these 2 points. Can draw this line. It's kind of straight here. And so I have that line, and then I want it to go through to the point 1, 5. So if I look at this slope of this line, is my slope of this line is -1. So the slope of my line needs to be this perpendicular, so it needs to be 1. So to get 1, I could either go up 1 over 1, or I could go down 1, left 1. And I'm going to do that so I kind of get until I cross this line. So this is a perpendicular line to it. And so I want to know what's the distance from here to here. Notice that point is -2, 2, which is what I had here. And so remember, distance, you can use Pythagorean theorem. So it goes up 3 over 3, 3 squared plus 3 squared plus 3 squared, and the square root of 9 plus 9 equals the square root of 18. So same thing, one's all visual and the other one is all algebraic. So either method you can use. I would pause the video, try that next one, and see what you get for this one. We can also look at the distance between 2 lines that are parallel. So again, we look at these lines and we know their slope is 2. And so my perpendicular line, because to find distance I need perpendicular, is going to be -1 over 2. We flip this and change its sign. So I can start at any point and do that slope -1 over 2. So one of my movements needs to be negative. So I go up 1 over 2 and have my other point, and so I have this distance. So we're going to write the equation of that line. Again, a few ways I could do it. I could pick a point, this point I started, write the equation. So let's look at that. Let's use that point. X is 0, y is -1, and I'd go y minus the y of my point, -1, y minus a -1 equals -1/2 x minus 0. So simplify that, y plus 1 equals a -1/2 x, and then subtract 1. Y equals -1/2 x minus 1, or also you could, like, you have your slope-intercept, which is -1, and you know your slope, which is -1/2. So I could write that equation without the point slope. So I have my line, perpendicular line, and I have these. So I can find my distance by figuring out where these two are equal and where these two are equal to get my point, and that would then find my distance from there. I'll let you kind of look at that and see if you can get that. If you again have questions, come in because this video is going to end here. So.